So let me start with this definition of intelligence. What is intelligence? Intelligence is an ability to reason and to profit by experience. And this is what the Webster's definition of intelligence. Individual intelligence is defined by a complex interaction, and the ingredients that define intelligence are judgment, common sense, interaction, and adaptability. We also say it's a sixth sense above the five senses what every human has got: vision, hearing, taste, touch, and smell. These are five senses which almost every human being has got. And above that, there's a sixth sense, and that's the intelligence. Intelligence is also a multifaceted entity and is subjective in terms of the perceiver. So usually in a group, you say, hey, this person is intelligent. In another group, you will say this person is not intelligent. So it's much more subjective than being actually objective. So why we are talking about intelligence here? Because we are going to study about artificial intelligence. Therefore, I thought I will take the definition of intelligence to start with. Now, let's actually, before we go into our course, our main course is machine learning. Let's actually go into the artificial intelligence. What is artificial intelligence? So today you are seeing the buzzword of artificial intelligence across the entire industry. It's not only being used in IT industry, it's used in healthcare, it is used in retail, it is used in manufacturing. You name the industry, it is actually being used. So let's look at what is artificial intelligence. So artificial intelligence is a branch of computer science concerned with making computers behave like humans. And there's the first definition given by John McCarthy in 1956. Now I tell you what actually happened in 1956. The first conference in Dartmouth actually happened where many scientists came together to define what is artificial intelligence. So before the artificial intelligence in the current form that is you are able to see, the research over a period of time has improved to deliver expert systems, logistics, data mining, and medical diagnosis before the true artificial intelligence emerged. The reason why this artificial intelligence actually emerged today, people are actually talking, the most important reason is, or rather one of the most important reason is the computational power has improved dramatically due to the Moore's law. So the Moore's law is a very famous law that has been defined in the late 1960s, where the power of the system actually improves year on year. So you are able to see today multi-core system, multi-core CPUs, multi-core what you call GPUs, graphical processing units, which are much, much powerful. Today, the smartphone is much powerful than a computer that was able to send the rocket to the moon in 1969. This computer that was able to send a rocket in the moon in 1969 was just a 64 kilobyte system, just for your information actually show. Because the computational power actually improved, the artificial intelligence field per se has improved dramatically. Let's look, before we learn about machine learning, let's look at the history of artificial intelligence. Why I'm talking about artificial intelligence when I'm talking about machine learning? I just want to tell you that machine learning is one of the branches of artificial intelligence. Therefore, we thought of defining what is intelligence, then what is artificial intelligence, then we'll go to the machine learning. That's the structure which we want to take the presentation through. So when you look at the history, The first history actually started in the year 1956 in the Dartmouth Conference, where two scientists, Marvin Minsky and John McCarthy, every aspect of learning or any other feature of intelligence can so precisely be described that a machine can be made to simulate it. So they define what is called an utopian definition, saying that intelligence can be so precisely described that a machine can be made to simulate it. So you actually have a human, you define an intelligence, therefore a machine is able to simulate it. That is what they defined it as, actually artificial intelligence. In 1958, Simon and Alan Neville said that within 10 years, a digital computer will be the world's best chess champion that will be able to beat a human. Did that happen? The answer is no, it did not actually happen until 1997. So what people actually aspired, what the vision they actually had in around 1950s, we were able to see the first achievement of that only in the 1990s. That means about this. In 1965, H.S. Simon, again, they all have put the vision that a machine will be able to do whatever a man will be able to do, whatever a human will be able to do. This is exactly the definition it told. Again, nowhere near, even now today, that is actually been achieved. 1967, Mervyn Minsky said, within a generation, the problem of creating artificial intelligence will be substantially be solved. Within a generation, when I say generation, it's actually say 10 years to 20 years. Was it solved in 1977 or 1987? The answer is no. But that's a vision, and that's what the people were aiming at. So what are the vision statements made by these gentlemen, or scientists? People were able to realize it down the line. That gave them a target, that gave them an objective to achieve. In 1970, Mervyn Minsky predicted that from 3 to 8 years, the machine will have a general intelligence of an average human being. Honestly speaking, it is actually becoming true today. That too, after 2005, that has actually become true, but never actually became 3 to 8 years. That was not actually true from 1970. So now you've seen the history of AI, what people spoke about AI. Now I just wanted to also tell you that here, from this point onwards, AI went through what I call as AI winter. What is AI winter? You know, winter people don't come out. People actually stay in their homes. Therefore, in AI winter from 1970, and I will say until 1980, there was not much of a breakthrough in AI. Then breakthrough started after AI, which you will be able to see down the line in my next slides. Before I actually go there, let us look at what are the traits of AI. Very important to look at the traits of AI. In AI traits, there are 5 important things what a human being has got, is what we would like to build in a mission. What are the 5 important traits? A human being is able to understand the natural language, is able to understand the voice, is able to recognize, is able to communicate. So any system which we call an intelligent system should first be able to understand the natural language, and we should be able to recognize the voice. Secondly, any system should have a knowledge. What is knowledge? Knowledge is nothing but a system that has got some data being converted into a useful data called information, and a useful data information is converted into knowledge, which all the humans actually possess as such. The third important thing we defined about intelligence. How can a machine have intelligence? Machine can have intelligence until we have algorithms incorporated into the machines. So what we call algorithmic intelligence. Algorithms are nothing but procedures, a set of procedures that are able to solve a problem. The fourth thing, learning. A machine should be capable of learning from the past experience, from the past success, from the past failures. The humans become more intelligent because humans have been trained to learn and learned because of the training, learned because of the real-time experience, therefore capable of learning. The last one is reasoning. The important trait is actually reasoning. For every problem that a machine solves, there should be a reason why the problem has been solved this way. So if I have to build a machine with what's capable of AI, it has to have the 5 traits, namely natural language recognition and understanding, knowledge representation, algorithmic intelligence, learning, and reasoning. Now let's get into the types of artificial intelligence. So at this point in time, I would recap what we have seen so far, so that we don't get ourselves lost in this particular session when we are going through so much of definitions and such. We started off what is intelligence. We started off what is actually artificial intelligence. We started off with the history or the vision of the various scientists, what artificial intelligence can actually deliver. They spoke about that. We spoke about the 5 traits of artificial intelligence. Now we will actually speak about what are the various types of artificial intelligence. Now, in this particular session, I mentioned the word AI. AI and artificial intelligence are synonymous. So wherever I'm actually referring AI, it refers to the artificial intelligence. The 4 types of AI are non-sentiment AI, typically focused on a narrow task. Suppose if you build a computer game to play a chess, then it becomes a very narrow task, an intelligent computer that can play a particular chess game. It is just playing only the game. It is not able to do anything else other than the game. Let's think about this next AI, strong AI, sentiment machine with consciousness and mind. So I would rather give an example for strong AI, a computer which is able to recruit a engineer, which is able to recruit a person into an enterprise. It has to have the consciousness, it has to ask the right questions, and it has to have the mind in order to take a decision. That is an example of a strong AI. Next one, a general AI. General AI is what all of us are, because we are all humans, okay, has the ability to solve any type of problem by applying our intelligence. The super AI. The super AI is the intelligence that is surpassing the humans. That's the super AI. So we have seen different kinds of AIs. Now, how these AIs are actually built, one of the ways of building the AI is machine learning. So let's not forget about the initial topic where we started. The course is all about machine learning. And we just spoke about AI because machine learning is a branch of AI. And now we'll go to the machine learning as such. Before we go into the machine learning, one of the important things that we actually have to learn, and it is a general aspect of learning, actually, which I would rather suggest. Anything that you go through, I would rather suggest that you have 3 questions: why, what, and how, in the same order. Why are we doing? What are we doing? And how are we doing to do? So when we look at the machine learning, why machine learning? Is it necessary? The world has made the machine learning very much necessary. So before we go into the other machine learning aspects, which is a branch of AI, we have other AIs, namely statistical AI, symbolic AI, and machine learning. The, the scope of this course is just the machine learning. Because why machine learning is important? It is important to understand the world has become data rich. Why the world has become data rich? There are a few reasons. One of the reasons is the internet actually started in around 93, 94. People started using internet. When people started using internet, they started actually browsing. They started actually buying from the internet. And therefore, the world became much more flatter than what it was. Therefore, there was communication about people, there was more data about the people, and there was easy to access uh, with respect to information. Therefore, information became much more easily available. The content became available much more easily. For world from 1993-94, when the internet started exploding, has become power, which again the Moore's law ensured the current hardware capacity increase by 2 times every year, 3 times every year. The processing power increased 3 times, 2 power 3 times every year. The second thing is storage. The price of the storage also is much, much lesser than what it used to be. You go to actually Google Drive, you get the drive free for about 15 GB. And if you want something like 100 GB, you just pay about $15. So the cost of the Google Drive is 100 GB, $15. And about 1 TB is actually much, much cheaper. This was not the case earlier. So when you want to see why machine learning, the idea of machine learning is to actually analyze the data and convert them into an information or knowledge that can be used by humans. And now the humans do not have the capability to do a huge amount of data analysis. As data analysis is pretty much limited by the capacity, by the capability of humans. Human doesn't have a huge amount of storage in the brain. So we look forward to the machine learning, actually see whether the 5 traits of AI, again, I go back to the 5 traits of AI, natural language understanding, you have the learning, you have reasoning, you have the knowledge, and you have the, what I call the algorithmic intelligence. If we apply all these things together, can we analyze all the data and get a useful knowledge? That's what we are actually going through with respect to the machine learning. That's the reason why machine learning is required. Now, when I say why machine learning, then you see what is machine learning. I go from why, then I go to position to say what is machine. So I'm going to introduce a term. Machine learns from training data. Now I introduced a new term called training data. Therefore, what is training data? Training data is nothing but knowledge, the way the humans learn from the past experience. We don't call it as we learn from the data. We actually say that we learned it from our experience. The machine learns from an experience. This experience is in the form of data. Because machine understands data, it does not understand experience. So experience is equivalent to a training data. Example of a training data is, say, today you actually came from your home to office, or you're going from home to office. Then what actually happens is the time taken or the distance is actually becomes a sort of a training data for the machine. The time taken is also a data. that distance is also a data. The second important thing with respect to machine learning systems is system will learn and improve with experience. System will refine into a model for better outcomes. An outcome can be what is the use of this large amount of data? Why are we doing this machine learning? We are analyzing large amount of data for finding a pattern, for optimizing, for a recommendation, for predicting. Today the weather prediction uses machine learning. Today we recognize the cancer patterns using machine learning techniques. We find out what is a malignant tumor and a benignant tumor using the machine learning techniques. We optimize the use of the energy using the machine learning techniques. Now, if you go to Amazon or if you go to YouTube or if you go to actually Netflix, you'll be able to get a lot of recommendation. If you have done certain things, the machine has learned from your profile and it comes back with saying that, hey, your interest is in this and therefore I would rather like to do this recommendation. So what is machine learning? Machine learning is data from training data. Training data is because you have been viewing certain movies or you have been actually reading certain books, that becomes a training data. Over a period of time, the machine learns from the experience and tries to model it to give what? To give a prediction, to give a pattern recognition, to optimize, and to actually recommend. Let's go to the definition of machine learning. Now we have seen why machine learning, we have seen what is machine learning. Now we'll go to the machine learning definition. The very fundamental definition started around something like computer's ability to learn without being explicitly programmed. You don't do specific programming in order to do this machine learning, and therefore the ability to learn without being programmed is called machine learning as per Arthur Simel in 1959. I want to just take your 1956 where the AI was actually born in 1959. But a very mature definition came because in around 1997, the very mature definition, a computer program is, machine learning is nothing but a computer program that is said to learn from an experience E with respect to some class of task T and a performance measure P, and its performance at tasks in T as measured by P improves with experience C. So if I have a task nothing, what is the definition of a task? A task is nothing but an activity that we are doing. And if it is measured, so any task is measured with a performance, and the performance, say you gave it as P, and if the performance actually, the measure of the task is performance, and the performance improves with the experience, then it is called a machine learning. What is experience here is nothing but learning. The performance is nothing but a measure of a task. How will you measure a task outcome? And task is nothing but an activity. So let's actually, if the definition by usually is actually much more cumbersome, so let's actually go back to the definition. What exactly is this particular definition? If I want to go from a place A to place B, then the task is going from place A to place B. And what is the performance here? The performance here is how fast I can reach from place A to place B. That could be one of the performance parameters. Second performance parameter could be my ability to predict correctly. That could be one of the second performance parameter actually. How is it actually improving with experience? So every day if I go from place A to place B, then I know approximately this much amount of time I will be able to reach. And if there is a hindrance, I will be able to reach in this time. Over a period of time, there is an improvement because of my experience, because of my learning. It's a very simple example which I've quoted. More real life examples, I'll be quoting it in the next few slides. Let's go back to the history of machine learning. We spoke about the history of AI. The first machine learning actually started in 1997 when IBM actually defined a program which defeated Gary Castro, the chess champion. It's called a deep blue computer. 1997. That's the first time machine learning came into what I call an existence. The second thing that actually happened was, what is the experience here? And again, every time when I actually go back, let me go back to the definition. It's a performance P on a set of task T, and it improves with experience C. What is the task here? Is to play the chess. What is the performance? Performance is a measure of actually how the task is measured. And what actually happened is able to defeat over a period of time the world champion itself. The machine learning is a program that was done. The second thing is that in 2005, a Stanford robot was actually able to do an autonomous vehicle, and it's able to check down a challenge. This is a Department of Defense, actually DARPA challenge, and the autonomous car driving started in 2005. That's a fantastic actually achievement in the history of machine learning, where a car was driven without a driver. The third, there's a gentleman called Dr. Jeffrey Hinton, who actually presented a unique paper on neural networks that led to what is called a deep learning. Again, I'm introducing a new term called deep learning. While you will be able to see these terms in the next few chapters, deep learning is a branch of machine learning. Machine learning is a branch of AI, and deep learning is a branch of machine learning. 2011, Google introduced its first self-driving car. In fact, in 2013, many states in US have approved the self-driving car with all the constraints as well. In 2016, while chess has got about 64 squares, there is a Go game known as a Go game is a Chinese checkers game. In 2016, there's a company called DeepMind in UK. It was later taken over by Google, defeated the deep Go champion in the world. Like 1997, the chess champion was defeated, world champion was defeated. And in 2016, you can see the entire Go champion has been defeated. So if you look at from 1997 to 2016, in a span of nearly 20 years, machine learning has made tremendous advances. It's able to learn, it's able to evolve experience, and it's able to defeat its world champions. Now, before we go into the machine learning, why machine learning we have seen, we'll actually see what are the problem types where you will apply machine learning. So what I've done is, for this particular introduction, I've defined 8 problem types. Real-time optimization. If I want, as an example, if I want to optimize the energy flow from a power plant based on energy pricing, weather, and other real-time data, I can optimize based on what I have learned. Again, optimization is a performance measure, and task is the actually delivering the energy to actually the homes or industries. And how will you optimize it? The measure of this optimization is the performance, and over our experience with the weather, with other real-time data. That's what real-time optimization is being used for machine learning. That's one of the problem types where the machine learning is used. Let me put it like this. Second is strategic optimization. That's one more problem type. You want to identify high-value customers based on the buying patterns and try and target those products much more specifically for those customers, which is a strategic thing which you think this customer will buy, and therefore that's a strategic pattern. The third is predictive analytics. You identify design problems in pre-production in the manufacturing to ramp up the maximum output. You identify it much before it goes into the production. Predictive maintenance. And today, Volvo is actually doing a predictive maintenance on their vehicles. When the vehicles have got what you call a signals being sent to a central server, where you will be able to recommend the status of the engine and recommend the proactive maintenance. That's one case where the machine is able to learn from the past data of this vehicle whether this vehicle is going to go down, therefore actually improve this availability before it goes down. Personalization. You go to Google, and if you've done certain profiles using your YouTube, or actually you are actually being given recommendations. You know, based on what you've done, what your interest is, you are able to see the personalization. And I would rather call, and this is a word from McKinsey, a radical personalization. Everything is changing radically into personalization. Next is discover new trends or anomalies. There are a lot of new things, new data is getting generated. Very specifically, now the people talk about a lot of cyber security attacks, cyber attacks. In this particular thing, how will you analyze a new pattern? We saw that machine learning is with respect to predictive analytics, pattern recognition. And because the world has become data rich, it's impossible for the human to find patterns of a large amount of data. So you require machines to find out the difference between the similar stuff. Difference between the similarities becomes a sort of a pattern. And that's what discover new trends we are actually using. Second thing is forecasting, predict future demands in a supply chain situation. Suppose you know that this demand is going to be like this, and therefore the potential constraints in the supply chain. So very a good example is, suppose if one of the companies identified there is a tsunami in Japan and is able to actually see that the supply is going to get impacted. Therefore, it's able to forecast that and try and actually improve the entire, predict the forecast, and then actually try and improve where the supply chain could be changed to. Last is process unstructured data. If you're navigating roads, a lot of unstructured data is actually coming in, some form of traffic, some form of actually obstructions. How will you do this navigation, autonomous navigation? That's another type of machine learning. And all the machine learning, and just to go back to the learning is a set of class task T done with a performance P, which improves over a period of time with the experience C. That's for the machine learning definition. Machine learning examples, which you're seeing the day-to-day example, which I will actually give you this particular example here. Good example is Google Maps. Time taken to travel along a route. The fastest route is being suggested based on the real-time traffic distance and the speed of the way, average speed of the vehicle, rather I will put that. What is the task T here? Predict the duration of a route and suggest the fastest route between the source and destination. That's the task T. What is the performance speed? Whether the predicted duration is close to the actual time taken. That is how the measure of the task is performance. What is the experience? Experience is learning. It collects the data from many users traveling the route or actually from the crowd and actually tries to do this particular, give you the prediction. And Google has to use day in, day out. Second thing is failure prediction. And I told you, Volvo predicts the next time a possible failure on engine based on your engine characteristics. What is the task T? Task T is to predict. What is the performance? Where the vehicle plays closest to the predicted time. That is what the performance. Okay, it will say that it's going to fail possibly in 2 weeks, and it's actually pretty close to actually that. The closer it's able to predict that the performance P improves. How the performance P can improve? Over a period of time, it handles a history of the vehicles and tries to improve the performance. That's another failure prediction. Very important, machine learning is actually using, well, I said the deep learning technique, which I will actually come back later. In Facebook, we have seen the faces are actually being identified. How? Because a face is a very difficult thing to identify because it has got about 120,000, roughly 120,000 parameters in a face to actually acknowledge. What is task T? To identify a person in an image. Performance, whether the person is identified correctly. The more the number of inputs about a face, the more accurately it's actually getting. A deep face technology is used today by the Facebook to identify a person. Why I'm giving this particular example is to actually relate this to the machine learning, what we have been trying to solve. So in this session, we learned about, what did we learn today? We learned about machine learning and AI definition. AI is artificial intelligence definition. We started off what is artificial intelligence, what is artificial intelligence, and what is the history of AI. We also learned about history of AI. We also learned about history of machine learning. We learned good examples of the problem types where machine learning can be used. We also learned about the example applications of machine learning, like for predictive analytics, pattern recognition. And I gave certain examples for this, actually, even for the face recognition as well. I hope this session has been useful. Thank you, guys. I'm done.